Alrighty. So when we are multiplying fractions, how do we do that? So 3/4 times 5/7. What the heck are we gonna do? Don't just tell me type in the calculator either. Yeah. We multiply across 3 times 5. So this is going to equal 15 over, and we multiply across 4 times 7. 28. Then we would look to see if we can simplify it. We don't have anything we can simplify here. So that's your answer for that one. On the next one, we could just straight up multiply across and then simplify. Or we can simplify beforehand because we know these are going to wind up as one big fraction where it's 4 times 3 and 5 times 2. 12 over 10. Or we could cancel out a 2. That's going to become a 2, and it'll simplify it early. So we get 6 over 5, which is the same thing as 12 over 10. Canceling out those common factors can happen at any stage in this. How about when we're dividing? What are we going to do there? Keep, change, flip. So we're going to keep our 1/2. Change our sign to multiplication. And flip the second one. 2 over 1. So what is 1/2 divided by 1/2? What does this simplify down to? 1. Keep, change, flip. And I did not pick these at random. Remember how we were simplifying polynomial fractions yesterday? I wonder what we're going to do with our polynomial fractions today. Ah! It's irrelevant. Who'd have thunk it? All right. So what we're going to be talking about today is we're going to be talking about our multiplying and dividing of our rational functions. And you can write this down if you want to, if it helps you. This is literally what we just did. Is when it's multiplying, we multiply across when we have division, it's keep, change, flip. And then we multiply across. So it's the same way we've been multiplying and dividing fractions for forever. Forever. So just because our fractions are going to look super gross doesn't change how we deal with them. So when we multiply across. For division, we do keep, change, flip. And then we're back to multiplying, so we multiply across. Keep, change, flip feels like it's like a cheat code or something, but it's multiplying by the reciprocal, which is a definition of division. It's a thing. We just use keep, change, flip because it's easier. All right, I still see a few people writing, so I'm going to give you a couple more seconds to write stuff down. And just like yesterday where we started with ones that didn't involve factoring, it was just our monomials in both in the numerator and denominator. We're going to do a very similar vibe today, where we're going to start with some non-polynomials, just monomials. Just a couple more pens going. Give me another few seconds. Gonna switch it in 5, 4, 3, 2, 1. So here's our first problem of the day. I'll zoom it in so we can actually see this a little bit better because I feel like it's a little bit small. So we've got 3x over 8y times 12x squared y over 9xy cubed. And we have been asked to multiply these together. When we multiply across. So I'm going to take my 3x and we're going to times the 12x squared y. I'm going to take my 8y times the 9xy cubed. And we have a couple ways we can go about this. We can simplify at the beginning or we can simplify at the end. And it really doesn't matter. I think it's kind of easier for our life if we kind of simplify as we go, just so we don't wind up with gargantuan numbers. So does anyone see something in here that can simplify? What is something we have both on top and bottom?
3.
The 3. I can take a 3 out of here and a 3 out of here. It's going to leave me with another 3. 4. Let's see, I'm going to get another color. So I can take a 4 out of 12 and a 4 out of 8. It's going to leave me with 2 down here and 3 up here. Anybody see anything else we can get rid of?
X squared.
Yeah, I was like, I'm going to go with the just x here and the just x here. So I've got a just x here and a just x here. And then I see the y. I can do that one too. I'm going to take that one and that one. And now it's getting really crossy-outy. So whether or not that we have anything else to do, I'm going to rewrite this because it's getting a little much. So I have left on the top, I have a 3 and an x squared. On the bottom, I have 2 times 3, which is going to be 6 over y cubed. Is there anything more we can do to simplify this? The 3 and the 6 will simplify. I can take 3 out of both of those. It's going to leave me with an answer of x squared over 2y cubed. Questions on this one? When we're multiplying, it's easiest to just kind of, I think of it as connecting my fraction bars and then simplifying as we go. Otherwise, we would have wound up with, like, what was it, 48? No, 36 over, yeah, big numbers. Annoying numbers. So here's our next one. We're going to do a division like this, and then we'll go into our ones that involve factoring. So division, before I do any simplifying, I need to do my keep, change, flip. So we're going to keep this first one, change our sign, and flip this fraction. So we're going to have our 10d to the 5th over 6cd. That stays exactly the same. I'm waiting to give you guys a chance to write. Sorry. I'll give you a second to write things down. So we're going to keep our first fraction. We're going to change our sign. So our division becomes multiplication. And then we're going to flip that second fraction. We're going to have 4c on the top and our 30c cubed d squared. So when we have division, I don't want you to try and simplify right away. It's too easy to go crisscross on things and have things cancel out that shouldn't. Once we're into our multiplication, then we can think of this as our simplifying step. What can we simplify here? The 10 and the 30. And give me a 3 here. I heard you, MRI, too. We got our 2. There's a 2 that I can take out of 4, and there's a 2 I can take out of 6.
We have 2 C's.
We have 2 C's. So I can definitely get rid of this C and that C.
Is it possible if we could do the D to the 5th or?
Kind of. Let's rewrite so that we can look at it. Because we are going to be able to simplify it, but we can't just like straight up cross it out. So we have left on the top right now, we have 2d to the 5th over, I've got a 3 and a 3, so it's going to give me 9 times d c cubed d squared. So there's a lot of letter D's over here. So altogether, how many D's are in the numerator?
5.
Breathe, lock it in. If I was to write it out long ways, d to the 5th is how many D's? 5 D's. How many D's are in the denominator? 3. So when we're coming to simplify this, I know I'm not just going to be able to cross them out. So I'm just going to combine those D's together. d to the 5th over our 9d cubed, c cubed. So what's going to happen with the D's? We're going to subtract the exponents. So this is going to give us 2d squared over 9c cubed. So when we have those exponents, those old exponent laws are going to come back into play. That 3 looked weird. Yes, ma'am. So we can see that. That's a 2 in this exponent. I will rewrite it. There we go. That one?
No, at the bottom.
Here? Or here?
Yeah.
This one? That's a 3.
Okay.
Oop. 6. So it's, there we go. Now it looks like a 3. Uh-huh. So the multiplying, the dividing, they're not super duper complicated. And we don't have to do any, factoring stuff. Snap. I wonder what's going to happen next. Okay. I know you thought I was joking at one point when I said we were going to have to factor 3 or 4 times in problems. I wasn't. So I want you to write this whole thing down. Yes, the whole thing. I'm going to zoom it in because I just have to fix a grammatical thing there. It just had it as an exponent. I don't like that. There we go. So we have here y squared plus 8y plus 15 over y minus 6 times y squared minus 9y plus 18 over y squared minus 9. And we are multiplying the 2 fractions. Who's up? Oh, yeah. The under the tree. I've got some. All right. So before we multiply these together, like we are not going to be doing distribution here. In fact, we're going to do the opposite because we're going to factor all of these before we multiply. Because we want as many things to cancel as we can. But we can only cancel stuff when its pieces being multiplied. Because I know for sure I don't want to wind up with y to the fourths because gross. So what we're going to do is we are going to factor all of these. Everything that has a square, we're going to factor. Yeah. I was not kidding when I said we're going to have times that we factor oblige. I was not exaggerating. All right. So I'm going to do this guy first. I have an a value of 1, so I can actually take a kind of shortcut when we're factoring. We just need our x, really, when we have an a value of 1. We're going to take our a times c on the top and our b on the bottom. My a is 1, my c is 15, my b is 8. What's a pair of numbers that multiplies to make 15 and adds to make 8? 5 and 3. These are what wind up as our factors. If you want to use the whole box, you absolutely can, but we're going to wind up with the same thing. With our y squared and our 15, 5y, that's a y, 3y. When you pull your factors, we wind up at y plus 5, y plus 3. It's the same values that are in here. Now, this only works when your a value is 1. But that's a shortcut we're going to be able to take, and it's going to save us a bunch of time if we don't have to do the box every time. If you want to do the box, that's absolutely fine. Our denominator on this side, does it need to factor? Do I need to run this through an x in a box? No, it does not have a squared, so it already is a factor. It doesn't have anything I can take out GCF-wise, so I'm just going to write it like this, y minus 6. So then let's come through and factor my right-hand guy. Very similar vibes. I'm going to take this blue one. We're going to do our a times c, 1 times 18, which is 18, and my b is minus 9. Negative 6 and negative 3. So again, we can notice that these are going to be our roots. So we're going to wind up with, use the box if you need to, but we're going to get to y minus 6, y minus 3. When my a value is 1, these are the pieces that go in my factors. One last piece for us to look at here. That's this guy down here. It's a special pattern, so you don't even need to use the x-frame if you don't want to, but you absolutely can. Multiplies to be negative 9, adds to be 0. What pair of numbers multiplies to be negative 9 and adds to be 0? 3 and negative 3. This is also a difference of squares, so if you spot that, that's, I think, easier. Where we have y plus 3, y minus 3. As you can see, I was not joking that we're going to factor a gazillion times. Gazillions. Okay. Now we are looking at the whole thing where we're multiplying and trying to simplify. Just like we did over here. We found some things that were same top and bottom that let us cancel out. So what things can we cancel out over here? The y minus 3's. Got one right here and one right here. What else? The y minus 6. And then the y plus 3. If it's the same top and bottom, we can cancel this out. So this whole thing simplifies down to be just y plus 5. That's a whole lot for y plus 5. Double check and see if I ask, because we could still look and see our excluded values here, just like we did yesterday. We can still look at that denominator and see if we have excluded values. I'm just seeing if I asked you that on the homework. Not specifically. So we don't need to work it. We'll work more with excluded values as we get closer to graphing stuff, but it was just something we were talking about. So this is our simplified answer right here. This is why I don't want you to try and brute force it and multiply it out. Because how in the heck would we have simplified to here? Factor it, cross stuff out. Questions on this one? Because we did monomial multiplication and monomial division. Then we did polynomial multiplication. I wonder what's next. Polynomial division. Oh, and look, X's, our very bestest friends. We love them. All right. I'm going to zoom it in so it's a little bit bigger. This is our last one for the day. We got x squared plus 7x plus 12 over x plus 6. And we are dividing it by 8x cubed plus 24x squared over x plus 6. All right, so I'm going to start. The very first thing I'm going to do is do my keep, change, flip. It is so much easier when things are in the places where they need to be. So the first thing I'm going to do is I'm just going to rewrite everything with my keep, change, flip. If you want to, when you're working on your own, combine this into one step where you factor and flip at the same time, that's fine with me. But I'm just going to do this now so we can see it. So we're going to have our x squared plus 7x plus 12 over x plus 6. That's the one I keep. I change my sign, goes from division to multiplication. And then we're going to flip this fraction. So we're going to have our x plus 6 on the top and our 8x cubed plus 24x squared on the bottom. So when we have division, the very first thing you're going to want to do is keep, change, flip. Then we're into exactly what we did on the last one, where I factor everything we can and then simplify. So, yes,
Can you cancel out x plus 6 if we still have to factor it?
I mean, we can cancel them out because we can see that these are just linear factors. I've got no issue with that. You can cancel them out right there. It doesn't change anything because we're still going to have to factor top and bottom anyway to see if anything else cancels out. But, like, you can absolutely cancel them out there if you want to. Totally fine. So let's factor this guy. I have an a value of 1, so I know all I'm going to need is my x frame. Multiplies to be 12, adds to be 7. 3 and 4. So we're going to have x plus 3 and x plus 4. Then let's look at this guy over here. All right, so it's a cube, which makes us go, ooh. So what am I going to do first?
You could tell they're both multiples of 4.
They are both multiples of 4.
So
Anything bigger?
8.
8. So they have a GCF here of 8, as well as what else? What else do they both have? X's. How many x's can I take out of both of them? 2. I can take out an 8x squared. And that's going to leave me with x plus what? What is 24 divided by 8? 3. So do we have any more simplifying we can do here?
X plus 3.
The x plus 3's cancel out. So we wind up with x plus 4 over 8x squared. We cannot simplify inside addition pieces. So this was one factor. We cannot keep going here. We can only simplify if pieces are being multiplied. So this is our answer. Do not try and keep going once we're down to just addition or subtraction in either numerator or denominator. You can only simplify pieces that are multiplied. So that is our answer right there. And our x plus 4 over 8x squared. Questions? Yes, dear. Yes. So, any other questions on this stuff? Awesome. I know I handed you a homework yesterday. Sorry, but you're getting another one. But then I will take your notes for another day. So I'm going to pass out homework 2, which uses the multiplication and division on the front, and then I write you. So the front side has 2 that are simplifying, and the other 5 are multiplying and dividing. The back is what we're going to do tomorrow and Thursday. So the next homework I'm going to give you is going to be on Friday. So I know I just gave you 2 in a row, so I'm going to give you another couple of days off on that day. Yes, sir. Yeah, I'll return it for passenger. Oh, I think that was like 6 of them. That's okay, you can just leave the extras there.